Good morning, ma'am.
Yeah, good morning, Peter. Good morning to all of you.
Good morning, ma'am.
Good morning. We start. Good morning, Peter. Good morning. So, just recall we had done the atomic mass. Remember the list I have given you, and the unit is U. So, atomic mass unit instead of AMU, right? Instead of AMU, what are we going to take? Only U for our convenience. But U is also atomic mass unit, but the unit is U. Okay? Understood, all of you? So instead of
Yes, ma'am.
writing AMU, we are writing only U. Got it?
Yes.
So just recall what we did yesterday. We did regarding atomic mass and how it is denoted as U. So you can start from hydrogen as 1U, and then the last one that we had come to was around,
Silver.
yeah. So atoms over, now we come to molecules. So molecules are bigger than atoms. I think you should know that. Molecules are made up of atoms,
Yes.
right, Beta? If I'm stopping you and asking something in between, I hope you will understand why I'm doing so. So while reading also you can explain. Okay?
Okay.
Start.
Number 4. Molecules and ions. The smallest particle of a substance is called an atom. An atom is very small in size and it cannot be divided further. Although atoms are the smallest particles of a substance, atoms of most elements are not stable and cannot exist independently. Therefore, two or more atoms of the same or different elements combine to form a stable entity
Entity.
called molecules.
That's it. That's it. What you understood from this para? That's why I stopped you because this is one meaning. The next meaning will come when we begin the next portion of the para.
Ma'am,
What did you understand?
in this, I understand that there are small particle called an atom.
Okay.
It is very small in size, and we cannot divide further.
Now don't read
We
the same
cannot
thing, Beta.
divide it.
Don't
We
read the
cannot
same
divide
thing.
into two parts, two equal
Not
parts,
two parts, many parts. It can
many
be
parts.
innumerable parts. Yes, exactly. And
And they
these
are
atoms, yes, yes, tell me.
these atoms are smallest particles.
That you have already said. See, for example, I'm just showing you. I cannot see, but I'm just showing you for the hypothesis to make you understand. Now, this is the smallest particle, right? I can see you can see the red dot.
Yes,
Yes, this is the smallest particle, which is known as atom. You cannot see. Remember that you cannot see.
yes,
And obviously, it's such a smallest particle that you cannot even imagine of dividing because I cannot see it. How can I divide it? Can you imagine? The
yes, ma'am.
smallest particle in the universe, can it be divided? No. So, this is the definition. This is the smallest particle which you cannot divide. Now, this smallest particle, which we call it as atom, they are not stable. That means they need someone to join. They need someone to unite. They need another particle of that kind to unite, to join, to become stable. Now, do you understand what I said? So, this atom needs another atom to make, you understand? Hello? Boys, do you understand now? These
Yes,
atoms
ma'am.
don't remain as one.
Yes,
They
ma'am.
keep on join. They want someone to join to become stable. So when they are single, they're unstable. So they're waiting for someone to join with them and to become molecule. This is clear.
Yes,
Is this
ma'am.
clear? So maybe it may be two atoms, it may be more atoms. Maybe it is of the same element or maybe it is of different elements. They come together, they join and become stable, and that stable entity or that stable condition is known as molecule. Is this clear to all of you?
Yes, ma'am.
For example, I take hydrogen, H. Now, can you see H as single? No. It always comes in the form of H2. Is it clear, beta?
Yes, ma'am.
All of you understood?
Yes, ma'am.
Yes? Okay? Hello?
Yes, ma'am.
For example,
Yes, ma'am.
oxygen. Let's say oxygen. Oxygen is also in the form of O2. Right, beta?
Yes, ma'am.
That's how you should understand.
Ma'am, ozone is O3 now.
Yes, beta.
Okay.
That is not present in the atmosphere. Remember that.
Yes, ma'am.
That's up in the, you can say, ionosphere.
In the
Near
space.
the space, yeah, near the space. So we cannot take that as that's O3 because O3 needs a process, it's a phenomenon. It's only forms up at the upper layer. It doesn't form in the atmosphere. It's not possible. You know that, right, beta?
Yes.
Yes, continue.
Hence, a molecule can be defined as the smallest entity of a substance capable of independent existence.
Okay. So what is the molecule then? So molecule is again that atom was smallest, remember that. But that was unstable. The molecule is stable. This is the only difference.
Yes, ma'am.
This is also a small particle beta. By joining of two atoms or three atoms or more atoms, it becomes a molecule. But even molecule you cannot see. That is also microscopic. So that is also, so we can say substance is made of molecules, molecules is made of atoms. Is it clear?
Yes, ma'am.
Yes, that's so. Now this molecule can live on its own, can stay on its own. Why did I say live? Because it is produced.
Yes,
Isn't it?
ma'am.
It does not form on its own. It is produced to make itself stable. So it can remain as such, whereas atoms are depending on others because they want someone to join with them and then form molecule. Do you get the difference between atoms and molecules?
Yes,
Molecules are
ma'am.
independent, whereas atoms are dependent. That's all. That's the difference. But both of them are tiny particles.
Yes, ma'am.
Do you want to ask me any question, beta,
No, ma'am. No
regarding
question.
atoms and molecules? Is it clear?
Yes, ma'am. Clear.
We'll do with an examples better. Start.
The constituting atoms of a molecule are held together by a strong attractive force. For example, H2 is a molecule in which two hydrogen atoms are chemically bonded. Similarly, hydrogen atoms can also combine with oxygen atoms to form water molecules. A molecule is the smallest particle of an element or a compound that exists independently and all the
Only
properties
possess.
possess
It's only
all the
possess.
properties of the substance to which it belongs.
Fine. Now let's take the example of hydrogen. This is one, this is the other. Agree, beta?
Yes,
And
ma'am.
how they are joined by a bond. This is called a bond. And the bond name is hydrogen bond. Just hear, hear me. You don't have to remember.
Okay.
What is the bond? Hydrogen bond. Very strong bond. So
Yes.
both of them are bonded together. See, how can they come together? There has to some attractive forces, and
Yes,
this
ma'am.
attractive forces is been defined as bond. Which type of bond are we getting over here? It's a hydrogen bond, very strong bond. So,
Yes,
and
ma'am.
that is keeping the atoms together. You know, that is keeping the atoms together. So it is an attractive force. Bond is an attractive force. So this is how what is formed with a H2 is formed. Okay. Now this
It's
was
true.
atom, one atom, this was the second atom, yes or no? And this
Yes, ma'am.
becomes molecule. So two
Molecule.
atoms come together, join together with the bond, which is the attractive force, and becomes H2 as a molecule of hydrogen. Is it clear? So if I
Yes,
ask
I'm
you,
clear.
if I ask you, one molecule of hydrogen will have what? Two atoms of hydrogen. Is it clear? One molecule of hydrogen is formed by two atoms of hydrogen. Am I right? Am I right?
Ma'am, your voice is cutting.
Just a moment. Now, beta?
Yes, ma'am, now it is perfect.
Okay. It's all net problem. It's all net
Yes,
problem.
ma'am.
So you can see over here that one molecule of hydrogen is composed of two atoms of hydrogen. Is it clear?
Yes, ma'am.
So molecule is what? It's the smallest particle of either an element or a compound. Now, if I say element, it could be Na or it could be Cl. But if I say compound, then compound is made up of combination of elements as NaCl, which is called a table salt. Is this understandable
Yes,
to all
ma'am.
of you? This understandable to all of you? So Cl is element, N is element.
Yes,
When
ma'am.
both of them combine together, they form a compound that is called NaCl. Now, this is independent. I think you know that. And it has all the
Yes, ma'am.
properties of chlorine as well as sodium. You understand? So NaCl has got all the properties of sodium as well as chlorine. Is it understandable to all of you?
Yes, ma'am.
I've taken different slides on the same topic
Yes,
so
ma'am.
that you will it will, because it's giving you something extra information, and
Yes,
moreover
ma'am.
it will be a part of your revision as well. Okay,
Yes, ma'am.
start better.
Number 6. Molecule. A molecule is the smallest particle of an element or compound which exists independently and shows all the properties of that substance. A molecule is a group of two or more elements that are held together by attractive forces. Atoms of the same element or different elements can join together to form molecules.
Now from this slide, what extra information did you get, or is it the same? Whatever we learned so far, is it the same or there is some extra information which you can add?
Same.
Same. Okay, but you check over here.
No, ma'am, shows all the properties of substance is different.
Exactly. That we did. NaCl, I think I talked about NaCl.
Yes, ma'am.
So I have already talked about it. The same thing has been put in a different manner. For example, they have defined molecule as a group of two or more elements, okay, which are joined together by attractive forces. What is this attractive force, beta? Bond. What is the
Bond.
attractive force? All of you are understanding,
Bond.
beta?
Yes, ma'am,
Yes.
understanding.
Now, this is about a molecule. Now, let's see about the atom. Atoms. It could be same, it could be of different elements. What do they do? What
Join
do they do?
together.
They join together to form molecules.
Molecules.
It's clear?
Yes, ma'am.
That's it. It's made into different format. Like molecule is a different, atom is a
They
different.
change the words.
Yes, they have changed the words. This is what I wanted to teach you. That even the answers that I give you, even you can play with the words, but the meaning should be the same. That is what I'm
Yes,
trying
ma'am.
to get at. Let's talk about this. What is this one, beta?
H2, hydrogen, oxygen,
O2. Say O2 first.
O2,
This one,
N2, nitrogen,
this one,
Cl2, chlorine,
chlorine. So this you
chlorine.
are. So what are these called? As diatomic molecules, isn't it? So a
Yes,
molecule is made up of two atoms. Okay. Now we come to different types of atoms, right? Got it? Different elements are coming together.
yes, ma'am.
What is this?
N2, nitrogen oxide.
Understood? Nitrogen oxide. What is this, beta?
H2O,
H2O,
water.
water.
So different element. Can you see different element? But here are
Yes,
three
ma'am.
atoms. Here are two atoms. Water. Very
Yes.
good. Which one is this one?
NO2, nitrogen dioxide.
What is this one?
CO2, carbon dioxide.
Hope you understood. How does it
Yes,
look
ma'am.
like? All of
Yes, ma'am.
you?
Yes, ma'am.
And all are attached with the pores. It's all bond. Understood, all of
Yes,
you?
ma'am.
You want to ask me any question, beta?
No, ma'am, no doubt.
Start.
Ma'am, can I read?
Okay, beta. But read properly,
Every
huh? I don't want you to be slow. Like Muhammad
yes,
Abbas is
ma'am.
reading very well. Yeah, I think you know that. Muhammad Abbas is reading very well. Huh?
Yes, ma'am.
I wish that be a bit, like dominant, give a nice throw, and be more active. Don't be slow, beta. Okay, start.
Every molecule has its own chemical formula depending upon the different atoms used. These are of two types. Compound formulas. A compound formula consists of the symbol of the elements found in the compound. Each elemental symbol represents one atom of the element. If more than one atom is represented, a subscript following the elemental symbol is used, e.g. water H2O,
Example.
two atoms of H and one atom of O are represented. Elemental formulas consist of only one types of atoms followed by the number of atoms used. For example, three atoms of oxygen are used.
Thank you. Now, what are they saying? Each and every molecule, they have their own chemical formula, right? How many atoms are used to make that molecule? That becomes the chemical formula. We are going to work on two types. That is, one is compound formulas and the other one is elemental formulas. Now, what is compound formula? So you should know that compound formula is bigger than elemental formulas. Do you agree with me?
Yes, ma'am.
Yes, ma'am.
Yeah. Okay. So compound formulas are bigger than the elemental formulas. So what is compound formula actually? They are made up of the elements. Obviously, we are going to use only symbols of those elements, which is available in the compound. Okay.
Okay.
Elemental symbol, that means the symbol of the element, it represents one atom. You agree? For example,
Yes, ma'am.
H. It represents one atom of hydrogen. It is an
Yes,
element.
ma'am.
You know that? Right. Okay. So, if we have more than one atom, for example, so what I make? I make a subscript. Subscript is, I think you know that, something which I have, for example, let's take H. So if I put something down, it is subscript. If I put something up, it is superscript. I think you know that, right?
Yes, ma'am.
Which I put down is subscript, and which I put on top whenever we talk about isotopes. That times I'm going to teach you what is superscript as well. So something on down,
Okay,
it is
ma'am.
subscript, something on top is superscript. So what are we going to use right now over here? Subscript. Okay, after the symbol, we will
Okay,
put
ma'am.
a subscript. For example, water. For example, we take water. So what is the
Yes.
subscript over here? What is subscript I have put over here?
H2O.
No, it is 2. Subscript is 2. So 2 is the subscript of hydrogen. And what is the subscript of what? Oxygen? 1. We don't write
One.
1. Remember that. We don't write 1. So we leave it blank. All
Okay,
of you
ma'am.
understood or not?
Yes, ma'am. Understood.
So what does that mean? What this H2O means? That it has two atoms of hydrogen and one atom of oxygen. That makes water. Is it clear to all of you?
Yes, ma'am.
And this is one molecule of water. Remember that. What you will say? This is one molecule of water made up of two atoms of hydrogen, that is element, and one atom of oxygen. Is it clear to all of you?
Yes, ma'am.
Yes, ma'am.
Hamza,
Yes,
newcomers,
ma'am.
there are many people. Are you understanding what I'm saying right now, Vita?
Yes, ma'am.
If not, then you can ask me again. Hello?
Ma'am, your voice is cutting.
Again?
Yes, ma'am.
Now? Now?
No, ma'am,
Now it is
not
clear.
cutting.
What happened, Moinuddin? What happened?
Ma'am, your voice is not cutting.
It's not cutting. Okay. Maybe Mohammed Abbas, maybe it's due to your Wi-Fi connection. Because otherwise it should be heard the same with everyone, right, beta? So does not matter. It will come and go. Don't worry. Okay. Is this clear about the compound formulas, all of you? Hello?
Yes,
Hello?
ma'am.
Yes, is it clear to all of you regarding compound formulas?
Yes, ma'am.
Yes, ma'am.
Huh? Okay. Now we talk about the elemental formulas. Now, as you know, element is what? Hydrogen, oxygen, chlorine. You got my point? These are all element, right, beta?
Yes,
Yes,
Yeah.
ma'am.
So one type of atoms. For example, hydrogen, how it is made by? Two atoms of hydrogen.
two.
Understood?
Yes, ma'am.
Now chlorine, two
Two
atoms.
atoms.
Oxygen, two
Two
atoms.
atoms.
Now we have a type
Nitrogen,
of
two
oxygen.
atoms.
Exactly. So you know that these are elemental formulas, right?
Yes, ma'am.
So what are we going to do? We are going to add the number of atoms to that element. For example, let's take up O2 and O3. Let's take up this example, right, beta? Both are elemental. What do you say?
Yes, ma'am.
Both are elemental. But only difference is the subscript is 2 over here and the
And
subscript is 3
three.
over here. Excuse me. So the first one is called as what it is called beta O2. What is the name of
Oxygen.
O2? Oxygen. And what is the name of O3?
Ozone.
Ozone. That's the only difference.
Yes,
But
ma'am.
elements are same. Do you understand?
Yes, ma'am.
So it is the molecule. O2 is a molecule. O3 is also a molecule. But
Molecules.
the only thing is that their definition changes. Is it clear?
Yes, ma'am.
Yes, ma'am.
You want to ask me any question, beta?
No, ma'am.
No, ma'am.
Now you got the element,
Yes, ma'am.
one type only. Whereas the compound, more than two types. Is it clear?
Okay.
You can see the H2O, hydrogen and oxygen.
Yes, ma'am.
Yes, so it is compound. Element, it will be either hydrogen or oxygen. You
Oxygen.
understand? Both will
Yes,
not
ma'am.
be together. That's element.
Ma'am, compound no?
No, no, compound is both. Element is either of them. Because
Okay, ma'am.
compound is made up of element, beta.
Okay, ma'am. Understood.
Compound is made of hydrogen and oxygen, whereas element is either hydrogen or oxygen,
Okay, ma'am.
both not together. Is it clear?
Yes, ma'am.
So compound
Yes,
is made
ma'am.
up of elements. Okay. Now see over here, you will have no problem now. What do you see over here? All these are elements, right, beta?
Yes, ma'am.
This is elemental formulas. And what the bottom one?
Compound.
Compound. Now, do you get the difference, beta? There's a reason why I took it again. This is the
Yes, ma'am.
compound. And what are we talking about?
Chemical formulas.
Understood now? This is how we are going
Yes,
to
ma'am.
symbolize. This is how we are going to learn. Tell me if it's clear, then only we can go to the next slide.
Yes, ma'am. Clear.
Clear. So more detailing we are going to do. Molecules of elements. Remember that. So you know that molecules are made up of elements. Molecules are made up of atoms. Do you understand now?
Yes, ma'am.
Yes.
Yeah. Start.
Molecules of elements. The molecules of an element are composed of identical atoms. For example, an oxygen molecule O2 consists of two oxygen atoms and a nitrogen molecule N3
Two,
consists of
two.
two nit
It is not
N2.
entry. Uh,
Yes, ma'am. consists of two nitrogen atoms and two NO2 are called diatomic molecules. Thus, the atomicity of nitrogen and oxygen is 2. When three atoms of oxygen combine, a molecule of ozone O3 is formed. Here, the atomicity
Atomicity.
of oxygen is 3. The number of atoms constituting a molecule is known as its atomicity.
So what did we learn over here? What is the topic that we learned?
Diatomic molecules and atomicity molecules.
It is only atomicity. What
Okay.
we learned? What we learned
Atomicity.
is atomicity. The whole slide is defining what exactly is atomicity. Now,
Yes.
if I ask you, okay, Peter, define what is atomicity. What you will tell me? What you will say? What is the meaning of atomicity?
The number of atoms constituting a molecule.
Exactly. So, number of atoms forming a molecule. In other words, is it okay?
Yes.
The number of atoms which form a molecule is called as atomicity.
Ma'am, one
Do you
question.
agree? Yeah, tell me. Do you agree with me this much?
Yes, ma'am.
Yes, tell me.
Ma'am, what is the difference between diatomic and atomicity?
No, there's no difference. You're confusing it. Diatomic portion is a part of atomicity.
Okay, ma'am.
Under atomicity units, monoatomic, diatomic, triatomic, polyatomic will come. You understand?
Okay, ma'am.
So atomicity is the number of atoms present in a molecule. That is all. Definition is over.
Okay, ma'am.
Now all this comes as a faculty, as a part. Monoatomic, if it is one atom. Diatomic, it is two atoms. Tri, three, tetra, four. More than four.
Yes, ma'am.
Polyatomic. Hope you understood. Is it
Understood.
understandable to all of you, beta?
Yes, ma'am.
So what is atomicity? Number of atoms present in a molecule is called as atomicity.
Yes,
For
ma'am.
example, let's take the example of oxygen, nitrogen. How many atoms makes oxygen and nitrogen? Two
Two.
atoms, right, beta? So there are two nitrogen atoms and two oxygen atoms. So what it becomes? What it becomes?
Diatomic molecule.
Understood? So one molecule of oxygen has got two atoms of oxygen, so it is diatomic. One molecule of nitrogen has got two atoms of nitrogen, again diatomic molecule. Is it clear?
Yes,
So
ma'am.
what I will say, the atomicity of nitrogen and oxygen is how much?
Two.
All of you understood?
Yes, ma'am.
Now let's take the third example, that is of ozone. In ozone, how many atoms of oxygen are present?
Three.
So what is the atomicity?
Three.
That's it. So atomicity of oxygen is 3. What does it suggest? That the number of atoms which makes a molecule is known as its atomicity. You want to ask me any question?
No, ma'am.
All of you understood?
Yes, ma'am.
Only Mohammed Abbas, you are saying yes. Rest of them are keeping quiet. So that's the reason I
Yes,
keep on
ma'am.
asking again and again. At least you have to reciprocate better. How do I know that you have understood?
Yes,
This
ma'am.
is very important. These things are very important. So I've taken slide by slide. Keep on asking me questions, beta, to make things easy. Because you are getting all new stuff. You can see you have not never been taught in 8th standard. 9th standard is absolutely different in science, isn't it, beta?
Yes, ma'am.
That's the reason why I'm asking you again and again. Okay, so I take it for granted that you know this atomicity now.
Yes, ma'am.
Yes. Again, it's a part of revision. You can start, beta. Okay, Mohammed Abbas.
Molecules of
Better let Mohammed Abbas start.
Molecule of elements. Molecule of an element contains atoms of the same element. Molecules of some elements contain only one atom, and molecules of some elements contain two or more atoms.
Example you saw.
Yes, ma'am.
Is This is the atomicity. Molecules of element contains atoms of the same element. For example, H2 and O2.
Yes,
Agree?
ma'am.
Molecules of some elements contain only one atom, and molecules of some elements contain two or more atoms. Ozone, O3, O2
Yes,
and
ma'am.
O3. All of you agree?
CuSO4.
No, no, not we will not take that. That is compound bitter.
Okay.
We are taking molecules right now
Okay.
of some elements or different elements.
Yes.
One atom, sorry, molecules contain only one atom, and molecules of some elements contain two or more atoms. That is what I showed you as O2 and O3. So it's got two atoms of oxygen and three atoms of oxygen. Is it clear?
Yes, ma'am.
Yeah. Then
Yes, ma'am.
atomicity of an element. What is it?
Atomicity of an element. Atomicity of an element is the number of atoms present in one molecule of the element.
So this we saw.
Yes, ma'am.
Yes. This
Atomicity of some elements. Type of element, name, and atomicity. Non-metal, argon, Ar,
how many atoms are there?
monoatomic,
How many atoms? One atom. So it
one
is
atom,
monoatomic. All of you
monoatomic.
understood? All of you understood?
Yes, ma'am,
Let,
understood.
let, let
Yes,
me
ma'am.
verify. All of you understood?
Yes, ma'am.
Yes,
So if
ma'am.
it Ar one, so we are not writing one, so we understand it's monoatomic. Second,
Okay. Helium, non-metal, He, monoatomic. Oxygen, non-metal, O2, diatomic. Hydrogen, non-metal, H2, diatomic. Nitrogen, non-metal, N2, diatomic. Chlorine, non-metal, Cl2, diatomic.
understood this much?
Yes, ma'am.
Now, should I ask you one
Yes,
thing?
ma'am.
Why did not we write one over here? It is not required. You
Not
understand?
required.
Actually, it
Yes,
is
ma'am.
not required. That's why we don't write anything. That means
Yes,
it has got only one atom. Is it understandable?
yes, ma'am.
Now we come to
Phosphorus, phosphorus, N non-metal, P4,
P4.
phosphorus.
No, it is polyatomic beta. It should be polyatomic. Okay? This
Okay,
one should come on top. Phosphorus is already written over here. So it should be because both P4 and SH both are polyatomic. Okay, beta?
okay.
Non-metal sulfur.
P4, polyatomic. Sulfur, non-metal. S8, polyatomic.
Exactly.
Sodium, sodium, metal. Na, monoatomic. Iron, metal. Fe, monoatomic. Aluminium, metal. Al, monoatomic.
So understood all of you?
Yes, ma'am, understood.
So non-metal we saw there were monoatomic, diatomic, and polyatomic. Metal we saw
Yes,
they're also monoatomic. So types, this atomicity is over. Okay, now we are going to work
yes,
on compounds. We did elements, we did compounds, sorry, molecules, and now we did molecules of elements. Now we are going to do molecules of compounds. Have you understood this much?
yes.
Yes, ma'am.
Can you
Molecule of
read or should I
compound.
read? Can you read
As you
better?
wish.
No, not that way. Is it legible? It's small. The font is small. Will
Yes,
you
ma'am, I
read?
can read.
Okay, then no problem.
Molecules of compound. The molecules of a compound are found when atoms of different elements combine chemically in defined properties. For
Definite.
example, definite properties. For example,
Proportions.
proportions. For example, the molecules of carbon dioxide (CO2) consist of one carbon (C) atom and two oxygen (O) atoms. Therefore, the ratio by number of atoms present in the molecule of carbon dioxide is C is to O is equal to 1 is to 2. This means that the ratio by mass of atoms present in the molecule of carbon dioxide C is to O is 3 is to 8. 12 into 1 is to 16 into 2 is equal to 12 is to 32, where 12U and 16U are the atomic masses of carbon and oxygen atoms respectively.
Are you understanding what are we doing? How many atoms of carbon, right? And how
Yes,
many atoms of oxygen are in which ratio? in this proportion they have joined
Yes, ma'am.
to form CO2. So different elements are combining. What are the elements over here, beta?
C,
One is
C
C
and
and
O.
other is oxygen. Okay.
Yes,
How
ma'am.
many carbon? One carbon. And how
One
many
carbon and
oxygen?
two
Two
oxygen.
oxygen. All of you agree?
Yes, ma'am.
Yes,
Standard, nice standard. All of you agree? So one carbon, one atom of carbon and two atoms of oxygen is combining to form one molecule of carbon dioxide. Is it clear?
yes, ma'am.
So what is the ratio? How it is formed? It is 1 is to 2. What is the ratio, beta?
1:2.
That is 1 carbon and 2 oxygen. Okay?
Yes, ma'am.
Now the ratio they are saying is, see, this is 12 is the atomic mass. So I will not go in detail right now. That I will do it later when we will talking about the calculation part, numericals
Yes,
part.
ma'am.
You understand? So let's keep it this much. I don't want to get into detail. That we will do it later. Is it clear to all of you?
Yes.
So the ratio, the way the ratio of the number of atoms present, same way the ratio of atomic mass is also constant. Do you understand? So that
Yes.
ratio